So with that, I will hand it over to Michael to run through some setup.
Perfect. Thank you, Peyton. Hey all, my name is Michael. I'm a partner solution architect at Amazon Web Services. Joined today by some lovely people, Yaniv from AWS, as well as the lovely people from Bridgecrew / Palo Alto, as well as HashiCorp. Please reach out via chat if you have any questions. If you need any help, we're all here to support you and get you through the process of this workshop. The workshop content can be found at workshop.bridgecrew.io as well as awsworkshop.io. Feel free to reference it now during the workshop as well as later. So the first thing that we're going to do is we're going to get into our AWS account setup. So let me share my screen so you can see what I'm taking a look at. Here we are. So the first place to start is the Event Engine dashboard. We're going to provide you all with AWS accounts today. They're distributed via our AWS Event Engine. You'll have access for 24 hours. That's going to be more than enough time for you to go through the workshop, try things yourself, break things, fix things, and really learn with Terraform Cloud, Bridgecrew, and AWS. A great way to learn without having to worry about costing your own environment. So you're going to log into this link that I think Yaniv has thrown into the chat. Please accept the terms and log in, and then you're going to end up on this splash screen. You're going to want to sign in. You can either sign in with a one-time password, where we'll send an email to you, your Amazon.com retail account. Those are your two options. So if we go the one-time password route, we're going to click that, and I have already logged in before. So otherwise, normally it will prompt you with your email. It'll send you an email with, I think, a 9-character code, and then you punch that in. So while we wait for you all to get your one-time passwords to log in, I'm going to provide a few little tips and tricks for the workshop and things for you to be prepared. A couple things that you might want to open up on your machine. One would be a note-taking app. You may be copying API keys, GitHub repositories, other names, and other code around. So having a note-taking app as kind of a staging area for all that information will be really helpful. So I would highly recommend having that open. The second one would be having the workshop itself open. So if we go to bridgecrew.awsworkshop.io, this will have all of the workshop content. And what we'll be going through today is the Terraform workshop, as we will be working with Terraform today. So once you have all that set up, you'll be pretty prepared to get the workshop going. But we're going to have to do a little bit of AWS account configuration to really get you started. So once you get that one-time password and you're able to log in, you'll see a screen very similar to this. You're going to want to get into the AWS console by clicking the Cloud AWS console button, and it'll give you this little pop-up, and we're going to open the AWS console. Once we get into the AWS console, we're going to be using our AWS cloud-based IDE called Cloud9. So if I search Cloud9, we're going to bring it up right here, and you'll see a screen like this. Another thing you can do is you can follow the link in the workshop itself. I'm going to move that back down a little bit. And here we are. So you can go to the Terraform workshop, as I previously talked about, click add an AWS event at 3.2.1 on the left-hand side. And then this will give you some of the more instructions to set up. The next one would be creating a workspace, and you can click the link here, and that'll take you to the same page as we see right here. So once you're here, what we're going to want to do is we're going to want to create this Cloud9 environment. So you're going to click Create Environment, and we're going to name it Bridgecrew-Workshop. And then we're going to go to the next step. You can leave most of the configurations as default. We're going to be creating a new EC2 instance, and we are going to want it to be AL2, but we are going to change one thing. You're going to click Other Instance Type, and you're going to change it to T3 Medium. Once that's done, we can scroll down and click Next Step. This will give you a little review page to see what you're deploying. We're deploying an EC2 instance with a T3 Medium type with the AL2 operating system. And then we're going to click Create Environment. Once we click Create Environment, the instance is going to start spinning up. Under the hood, if we look at AWS or console.aws.com, and we go to CloudFormation, we can see that, or once we refresh CloudFormation, we can see that once we click to create, a CloudFormation stack started to get created with all of the necessary collateral for this EC2 instance to live, such as the instance and the security group. So that's what's happening under the hood when you click that create button. The great thing about Cloud9 is it automates all of this for you. It'll create the instance. It'll get this all set up. It allows you to run your code on AWS, write your code on AWS, and it comes prepackaged with tons of popular tools and languages. It comes with Python. It also comes with Terraform. So you have a consistent environment to work with, and it's convenient and easy to spin up. Once we have all of this set up, we now have logged into Cloud9. We have a couple of pop-ups which we can close, but we're going to kind of finish this off with running a few commands via the bash terminal to get us started. So if we go back to our workshop, we're going to go to the next step, quick setup, and we're going to copy a couple of commands. So the first thing we're going to do is sudo yum install JQ. So we're going to install JQ for parsing any JSON that we'll need to do. And then this is going to install itself. And I think I might have to press yes. And then the next thing we're going to do is we're going to make sure our Python virtual environment is set up. Oopsies, I was a little premature in that. And then we're going to paste that in. And there we go. So our Python virtual environment is set up, and we are good to go. The next item that we'll have to do is we'll have to set up Terraform in your Cloud9 and make sure that your Cloud9 has credentials to access Terraform Cloud. What we're going to do is we're going to go Terraform login. And this will prompt you to set up your Terraform API key for this Cloud9 instance. So you're going to confirm that, yes, I am interested in logging into Terraform here. And then it's going to ask for your API key. The lovely thing here is you can follow this great link, click it, and then open it. And then you'll be able to follow the instructions on Terraform Cloud to create an API code. You can give it a description and then copy and paste it in. I'm not going to do that because I don't want you all to see my API key, but it'll give you your API key right here, right now. And then you can copy it and paste it into here. I'm going to put in a silly value. It's going to say no because it is not a real token. So that is the AWS setup and setting you up with Terraform for Cloud9. I'm going to hand it off to Prakash, and he's going to talk a little bit more about Terraform Cloud and walk you through that side of things. Prakash?
Okay, thank you, Michael. I'm going to go ahead and share my screen. Okay. Okay, can you guys see my screen?
Yes.
Okay, good. So what Michael showed you was setting up the virtual environment on Cloud9 to be able to access, setting up the workshop stuff you're going to do. You can also do it on your own AWS account if needed, but it's so nice of AWS to provide us the free account for this workshop. One of the things is you would need a free account at app.terraform.io to take advantage of the Terraform Cloud features. What I did was, you may already have an account. If that's there, you can just create an account from app.terraform.io, and then you sign up. It'll go through a process. But once you log in, you will see a page like this, a welcome page. So I would click Start from Scratch, and it'll ask you to create an organization name. And this is just a name, a unique name that you need to put up, something like this. So this will create an org where you will create all the workspaces needed for you to run Terraform code. The way it works is your Terraform code resides in a Git repo or on your local machine, and then you can connect it to Terraform Cloud. And when you do the runs will happen within Terraform Cloud, and Terraform will take care of managing the state. We will discuss about this a little bit more. I just want to show you how this is set up. So the first part will be to create a new organization. And once you have done this, there are two things we will have to do. First is to go to settings on the top blue section, and enable. When you get started, you're on a free plan. But in this workshop, you're using some advanced features such as Sentinel integration for us to work with Bridgecrew. And in that, you'll go and change the plan to the trial plan. So this will be the one. So you'll be on the free plan, you're switching to the trial plan, and then you start a new free trial. So to access this, you go to the settings on the blue, and then click on plan and billing, and then we switch that. So that is one thing you'll have to do. The second thing will be to, Michael talked about the token that you will have to generate. When you do Terraform login, it'll point you to a URL to get the token. But in case you're wondering where the token resides, it's on the user side. You have user settings, and then you have the token. So when you create a token, it'll be listed here. But if you don't have it, you can just go ahead and create a token, put in a name, and then it'll create the token that you can copy in, that what Michael just showed. So that's the basic setup for Terraform Cloud, and I'm going to pass it on to Taylor now.
Awesome. All right. So before I jump into what I'm going to do with the workshop, I just want to double check that everyone has their prereq set up. So I'm going to do a quick screen share. And all right, so you should have Cloud 9 with your virtual environment stood up. You should have Bridgecrew set up and logged in. Make sure you go to bridgecrew.cloud if you haven't yet and sign in. And the account is free for 14 days, so don't worry about setting that up. And then there's GitHub. So make sure you're logged into GitHub. I have a fresh new instance here, and then your Terraform Cloud account. So just make sure those 4 things are up and ready to go. All right. I'm gonna give everyone just a minute, and oh, sorry, chat window showed up here. Okay, so give everyone just a few minutes. Now, don't worry if you're following along. The directions are always on that workshop.bridgecrew.io. And we are following the Terraform workshop path. So just go here, and all the prereqs are the ones that we were showing off just now. So just follow that prereq path. Okay, great. So what I'm going to do is I'm going to start presenting, and if you're still setting up, don't worry, we're not going to jump into the actual clicking around in the workshop for a few minutes. All right. So first, I wanted to hand it back to Prakash and just do a quick introduction about Terraform.
Okay, thank you, Taylor. The first question is why Terraform? And a few years ago, when I just started developing the cloud, we had to set up a development environment which involved a VPC, a couple of instances, and probably a database. And it was pretty easy to go to the UI, AWS UI, click, and you can set up your development environment. But once we finished development, the challenge was we had to replicate the same environment for a test environment and then finally to production. And we quickly found out that we were making configuration mistakes and it was taking too much time to do all this. And team members didn't know exactly what was being configured. And then it was like, we needed an automation tool. And this is where Terraform comes in. Terraform is a very elegant, declarative way to declare your infrastructure. And then it provides the tools needed to provision it. By putting everything in code, you get the benefits of a code-based workflow. So developers define the infrastructure as code, put it in a Git repo, and they can collaborate. They can make pull requests, merge requests, and then use that to run and execute, and you get consistent infrastructure. So you get the same dev, same test, and then the same prod without any issues. So that's what Terraform provides, a consistent way, a consistent workflow to deploy provision infrastructure, and not just for AWS, but it could be for any infra cloud out there. It could be for Google, for Azure, even for your router. So Terraform provides a number of providers that can allow you to codify that infrastructure in Terraform, and you get the same with the same workflow you're getting. You're able to manage all this infrastructure. The next step, next slide, Taylor. So this is kind of on the left-hand side. Terraform is obviously an open source core. It's an open source core, and that's the kind of the workflow where you have the practitioner writing some Terraform code on their local machine, and then using the plan and then apply to first see what the change is going to be, and then able to deploy code in all these different clouds. With Terraform Cloud, you get the same benefit, but it's scalable. It allows people to collaborate. So Terraform open source is really good if you are 1 or 2 person team, but when you want to grow, you come up with other challenges. So Terraform Cloud provides you a way to come up to solve these challenges. And Terraform Cloud has a free tier, so you can use it to store your state file and so forth. But the paid tiers provide you advanced features such as governance, role-based access control, so that you can make sure that the right people have access to the right parts of the infrastructure. So that's all I have for now, but back to you, Taylor.
All right, thanks, Prakash. All right, so we know Terraform is valuable and it really helps with provisioning infrastructure, but what we're missing here is the security piece. And so that's why we're here. We're talking about DevSecOps, and this is incorporating security into the DevOps model. So DevOps was the movement that combined operations and development. You have a spectrum of how that works, where you have like the Spotify model of you build it and you run it, all the way to just tighter collaboration between the two teams. So you have operations people showing up in development meetings and in design sprints. And we're doing the same thing now with security, where we're embedding security earlier in the cycle and throughout. So you have security experts showing up in design meetings so that they can have security inputs and make sure that your cloud infrastructure is secure by design. And then wrapping that all the way through, so it's secure all the way to through the integration, through the deployment, and then in runtime. And so really that's what we're talking about here. Some of that is the tooling, like Bridgecrew with automation of your security, and some of it is closer collaboration between the teams. So we're going to do a quick overview of the workshop. What we're basically going to do is we're going to show off Checkov, which is our open source tool that does policy as code. So we'll check for misconfigurations in your Terraform templates locally. And then we'll show what that looks like in GitHub in your repository, as well as an integration with Terraform Cloud as your CI/CD. all the way through to runtime. And then we'll tease what it looks like for when you detect drift. And we'll talk a little bit about what drift is in this context. All right, so with that, I'm going to jump into the workshop. At this point, I'm going to assume everyone has their prereqs up and ready to go. I'm going to start by heading into the Bridgecrew platform, and then let's go down to integrations. And let's look at, we're going to add an API token. And let's just call it workshop. All right, so this is going to generate a new API token. So again, I'm in Bridgecrew, I went to integrations, API tokens, and let's create that. And I'm going to delete this token afterwards, so you can copy it, but it won't do you much good. All right, so I'm going to copy that over. And then what I'm going to do in Cloud 9, when I go over here, is I'm going to add in your BC API key equals and my API token. Now, this isn't a required step. This just makes it a lot easier to follow along in the next few things I'm going to show off. So just pausing here for a second, make sure you have your BC API key equals and the API token you just created from Bridgecrew. So make sure that's good to go. I'm done here and back to Cloud 9. All right, so I have all my prereqs ready to go. Now I'm going to go to the next stage. And if you're following along, I'm now in the module scan. So I can show you here, module scan. All right, so let's head over to GitHub now. All right, so in GitHub, what I'm going to do is I'm going to search for TerraGoat. And TerraGoat, you can either search for it or go to Bridgecrew.io, not Chekhov, but TerraGoat. So again, github.com/bridgecrew.io/TerraGoat. It's also this link right here. And I'm going to fork that. So that's up in this upper right corner. What this is going to do is essentially, if you're not familiar with GitHub, it's going to create a copy of the TerraGoat repository, but in my environment. So now it's a new copy that I own rather than the one run by Bridgecrew. All right,
Peter,
so yeah.
Quick question. So do you have to copy this repo or can you just run it from the existing repo? Is this copying required?
So it's a good idea if you want to mess around, if you want to add pull requests for new things to make a copy. You could do some CI/CD from somebody else's copy of TerraGoat if you wanted to just skip some of these other steps.
Okay, sounds good. Thank you.
Yeah. All right. So now that you made a copy, I'm going to do a quick overview of what TerraGoat is. TerraGoat is our vulnerable by design Terraform instance, or Terraform templates. So if you look in here, we have a whole bunch of Terraform, and under AWS, we have a whole bunch of Terraform files like this EC2, and these are working Terraform files. So they will provision a working instance with an attached EBS volume, with snapshots. So it's a working instance. This will work if you do Terraform apply. It will work. However, it has a whole bunch of misconfigurations by design. So we kind of reverse engineered. We took a bunch of the misconfigurations we know about, and we reverse engineered that into an example. So once you have that copy, what we're going to do is we're going to make a local clone of this in Cloud 9. So first things first, if you're following along, just here, I'm in the TerraGoat section under clone a copy, and I can just copy this and then head over to the Cloud 9 IDE, just paste it. Oh, sorry. First, I need to make sure that I change the organization. So take this first line and I need to change the organization to my organization. Now, it might be easier to just copy the URL you have me just confirm that I got that right. Yeah, Tastemit test, Terragoat. All right, so it has your git clone, the link to your Terragoat instance repository. All right, so now you should see it's cloned. And then let's just change directory into the Terragoat. And then let's just double check the git status. On branch master, nothing to commit, working with a clean tree. Great. And so you can also see over here in Cloud 9, we have that same tree structure. So we have a whole bunch of Terraform templates for AWS here. So at this point, you should have a clone in your IDE. You should have a fork in GitHub. All right. So the next thing we're going to do is we're going to add Chekhov. Now, what we need to do to add Chekhov is we need to install it. The nice thing is that installing Chekhov is very simple. It's just pip3. Let's do sudo pip3 install Chekhov. So it's just pip3, your Python installer, Chekhov. So we'll give that a second to install. Now, as that's installing, Chekhov is our policy as code scanner. So it's going to do a local scan of what misconfigurations are identified in your Terraform templates or CloudFormation templates or a whole bunch of other IAC templates out there. All right, so make sure that this is installed. Let's just do Chekhov version. Great, we're on the latest version 2.0. Now that I have my Terragoat repo, I have Chekhov ready to go. I'm just going to do Chekhov-file. So there are two options here. You can either do -f, which is a single file, or you can do -d, which is a whole directory. And so I'm going to just do a single file in this case. And let's do, so in this, I'm going to follow this tree structure. I'm going to go Terraform, AWS, and then I'm going to do, let's just do EC2. So what this is going to do is a quick scan of the Terraform EC2 template. And this is a local scan. So none of this ties back to the Bridgecrew platform. It's just showing me all the misconfigurations, like this S3 bucket has public access. And it shows me all the different misconfigurations in that EC2 and EC2 Terraform file, as well as the things I've passed. And then up top, we have a nice summary here. We have the number of passed checks and the number of failed checks.
Hey, Taylor, quick question.
Yeah.
So the Chekhov binary comes with built-in policies in the binary itself, or can you have your own set of policies and then assign it to that binary?
Yeah, it's a great question. So Chekhov comes out of the box with, at this point, I think we're at 1,000 policies. And those are pre-canned and they're able to detect if you're scanning a Terraform file or a CloudFormation file automatically. And then you can also, in either Python or YAML, add your own custom checks. So you can go in and if you have your own reasons for scanning or your own things that you want to check for misconfigurations of, you can always add your own custom policy. Cool.
Another question, this is really cool. So you said that Chekhov can be used against CloudFormation and Terraform. Does Chekhov internally convert both of them to kind of a standardized format so that you can write one policy and it can check both, or you have to write separate policies for CloudFormation, separate policies for Terraform?
Yeah, it's a great question. So if you're writing in Python, you can actually have them in a single format. So you can have a single check for both CloudFormation and Terraform if it's an AWS check.
Great, thank you.
Yeah. Awesome. All right, so we've done a local scan. Now, what we can do is we can tie these scans back to the Bridgecrew platform. And what this will do is it adds a nice layer of having a history of your scans. It also brings all your scans in a central location. And it also provides some fixed suggestions that are only available if you have the Bridgecrew backend. What we're going to do then to do that is simply add in our API key and a repo ID. So it's as simple as that. So if you head back over here and let's go to the Chekhov section, we can just copy this same one. Up top, you can see in this case, we're doing the Terraform S3 Terraform file and then our API key. Now here you can put your API key that we copied earlier, or if you did that, where you actually did the check, where you added the variable in the CLI, then you don't need to change this at all. It should just be copy paste. So I'm going to go ahead and copy and paste that and then scan. And it's going to check this S3 Terraform file now for misconfigurations and also send that report to the Bridgecrew platform. And this is how it's going to show up in the Bridgecrew platform. So it'll be under Bridgecrew IO/S3. Give that a second to run. All right. So now you can see it's similar misconfigurations, in this case for an S3 file. But at the bottom, we have this link now, and this takes you to the projects page, which I'll show off in a bit, that has the direct link to this scan. So I can find that scan history in the later date, and along with some of the custom fix or some of the recommended fixes. Now, if you want to see a bunch of the policies that come out of the box there, you can always go to the GitHub repo and they're all there since it's open source, but you can also check it out here by doing Chekhov --list. And so you can see here are all the thousands of misconfigurations that we identify, including secrets. And the other thing that you can do if you want to, you can add in so doing Chekhov help, you can add in the exact template type that you want to check. So that includes for, if you're scanning like a monorepo that has Kubernetes, Terraform, and Docker files, and you just want to scan the Kubernetes manifest, you can add in that. So you can say, let's see, where is it? Framework right here. So if you do -- framework and then Kubernetes, that'll just scan Kubernetes. All right, so that is Chekhov in a nutshell. There are a whole bunch of other features you can see here, like you can set a baseline where it'll skip those checks in the future. You can set it to be soft fail or leave it as hard fail. You can always add in skip checks. So if a certain policy doesn't apply to you, you can skip those in the future, or you can only check for specific checks. So you could say, do this specific check, so -C, and then just list out the different checks that you want to do. All right. So the next thing that I'm going to do is I'm going to head over to, we're going to do the integrations now. So if you're following along in the workshop, I'm now on the automate. Yeah.
Taylor, quick question. In Terraform, you can have variables, and then Terraform code could use variables to do its configuration. So how does Chekhov, does it also read the variables file, or it is just looking at the code?
Yeah, great question. So it's one of our differentiators over some of the other open source scanners out there. We do variable rendering. So if you have the variable file in the same directory, if it's something we can reach, it's not stored privately, then we will build out the plan. And so we're actually scanning the built out rendered variables.
Great, thank you.
Yeah, it's a great question. Awesome. Okay, great. So the next thing I'm going to do I'm gonna do a quick touch on the Bridgecrew action or GitHub actions, but we're not actually going to add this step because there's already an example of this in TerraGoat. So in GitHub, make sure you go to, so you're in the TerraGoat repo that you forked, and you go to actions, and then let's just turn this on. So I understand my workflows, go ahead and enable them. All right, so I have actions enabled here, and I'm just going to do a quick show of what that looks like. So under GitHub workflows, you can see I have 2 actions here already, and these came, if you fork TerraGoat, they're already in there for you. So under Chekhov YAML, you can see what this is doing is it's on every single push to branch master. It's doing a Chekhov scan, and it's also running YOR. And I'll show off a little bit of what YOR is, but YOR is essentially our automatic tagging open source tool. So it's another one of our open source tools that we offer. What it does is with every single file out there, it will tag it with information that's helpful for fixing problems. So as an example, if I go to Terraform, AWS, and then EC2, if I go down here, you can see some of these tags are unique. So this one was added manually, but all these git commit, git file, etc. were added by YOR. So when somebody pushed this code to production or to the master branch, YOR automatically added in the git commit, which is a unique ID, the git file, so that's this EC2 file, the last modified at the modifier, so in this case it's Nimrod, and then the modifiers, the org, which is Bridgecrew IO, the repo, TerraGoat, and then this YOR trace. And the reason why I went into that detail is because YOR trace is very helpful in trying to figure out a problem. If you're searching, if you found an issue in production, let's say you found an S3 bucket that was unencrypted, that tag will carry through to production. And so you can just quickly in AWS search for, find that tag, this YOR trace tag, search for it in GitHub, and it will bring you right to this resource block. So not just the file, but the actual resource block, that's the problem. So it really helps speed up triaging and fixing problems. And this is built into TerraGoat, but you can add it in as a pre-commit hook or as a GitHub action, or any CI/CD pipeline should be able to add it in. All right. So that's a quick touch on GitHub. So just again, make sure you have your actions turned on in GitHub. We're going to next do the integration with GitHub applications. So from here, what we want to do is we want to head over back to Bridgecrew. And you can see here's our Chekhov scan that we did with the API, but we're going to add another integration. And for this, it's really important that you're already logged into GitHub, and it'll make it a lot easier to do. So you can see here are all our different integration options that you can try out for yourself, but we're going to do the GitHub integration. And so you can see it's very simple to set up. We have to choose a GitHub organization to configure, and then review the requested permissions. So if we take a look, I'm going to do all repositories. You could do select repositories and just check TerraGoat. In my case, I have a dummy account, so it's okay to just do all repositories, but you could do just the TerraGoat one if you want, and then install and authorize. And I'm going to add my password. All right, and that's it. So that the GitHub application is now set up, and then I'm just going to check the repository, make sure it's TerraGoat, and then hit next, and that's done. All right, and if I refresh this, it should show up. And that's going to start scanning in the background. It's going to start scanning my TerraGoat repo. If you selected a whole bunch of repositories, this might take a few minutes. But if it's just one repo, it should only take a few minutes. It should be fairly quick. So just to recap, I went into integrations, I found GitHub, and I added that integration. And I went through the steps to add it. And so now that's added and good to go. The next thing I want to do is under settings, code repository settings. Make sure code reviews is turned on and make sure pull request bot comments are turned on. They should be turned on by default, but some people in past workshops have turned them off. So I just always like to check, make sure that you have them turned on. All right, so at this point, you can see some misconfigurations are already coming in into the platform through the checkout scan and also through GitHub. And we'll go over that in a bit, what that looks like. But first I want to do the projects page. So if you think of the incidents page as all your misconfigurations across build time and runtime, your project page is just your build time misconfigurations. So this is the checkoff scan, you can tell from the BC logo. And then we also have our TerraGoat repo. And so this is still coming in. We'll see a lot more misconfigurations here, but you can already see that I have a whole bunch of Dockerfile misconfigurations, and pretty soon we'll see a whole bunch of Terraform misconfigurations in here. So I'll give that a minute to populate. And while that's populating, I'm going to head over to, we're going to do the next step, which is the Terraform Cloud integration. All right. So in Terraform Cloud, this is, as Prakash mentioned, a very cool tool where you can really simplify your CI/CD pipeline specifically for Terraform. And we have two integrations. One is just about to be released, which is our new run task integration. And I'll kind of tease what that's going to look like. And then we also have our Sentinel integration, which is the one we're going to use. So the first thing we're going to do is we're going to go to workspaces and create one. So let's do a new workspace here. And we're going to do a version control workflow. And let's do GitHub. So this is my other repo. I'm going to actually add another organization. And again, it's going to be either all repositories or just the TerraGoat one. I'm going to do all repositories and install it. Let that take a minute. So again, I was in workspaces and I added a new workspace. I chose VCS as the type, connected it to GitHub. I added my new GitHub. Let's see, it should have worked. Let's see what's going on. Okay, that's good to go. Failed to install. Let's see. Let's try it again. All right. I'm just going to do a quick refresh. To version control, GitHub. Give that a second, and then add a new organization. All right. And let's see if just changing this will work. I might need to, nope, failed to install. All right, I'm going to do a quick, let's just uninstall the integration here. So let's do uninstall. Okay, so that's uninstalled. Just refresh this. Do version control, GitHub. Give it a second. Let's add another organization. I'm going to do all repositories and install. All right, hopefully that works. That is not working. Let me see. I might want to do, I'm on, give me 1 second. I'm going to see if I can get this. It's always something. So we'll get this figured out. All right, let's do. What I'm going to do is I'm going to remove. I'm going to remove this other integration that I have here and see if that works out. All right, apologies for this. Sometimes the demo gods do not stand in your favor. All right, so if I go to version control, GitHub, that's all set up, which is great. That failed, that's fine. We'll do this. Start from scratch. All right, this is looking promising. So we'll go under GitHub, and then authorize Terraform Cloud. All repositories, install. Great. All right. Sorry about that. Okay, so now I have just my TerraGoat one. In this case, it helped to remove all the other integrations I had with Terraform Cloud. I had one other VCS integration. So that figured it out. All right, and the workspace name TerraGoat is fine. We'll keep that. Under advanced options, so under advanced options, what I want to do is I want to change the working directory to simple instance. And the reason why I'm doing that is because we're going to do kind of a simplified flow where we add a new Terraform file to our repo. And I don't want to have Terraform Cloud try and deploy the entire TerraGoat repo. I just want to do the new one that I'm going to send out. So again, I've gone through the choose type, connect VCS, choose repository, TerraGoat, and then under configuration settings, the workspace name is fine. Under advanced options, I'm going to do Terraform / simple instance. And we're also going to turn on automated speculative plans. Great. All right, so that should be good to go. So again, I have Terraform / simple instance and automated speculative plans turned on. And I'm going to just double check. All right, I'm going to create that workspace. So that is good to go. Fantastic. Next, I'm going to do my configure variables. So under variables, what we need to do is we need to add our AWS access key and secret access key. So again, in my workspace variables, under environment variables, I'm going to add 2 variables here. So the first one is, again, if I'm in here, let's go to the Terraform Cloud. And make sure, let's see, where am I? Okay. So here we want this AWS access key. And under variables, AWS access key. And then for the actual access key, I'm going to take this from the dashboard event engine.run. And I'm going to copy the access key ID, make that sensitive. And then I'm going to add a variable. Thank goodness that AWS has helped us out with the event engine, so it doesn't matter if I show this publicly. All right, we'll do secret access key. And then here I will copy the secret access key. Make that sensitive and set that variable. All right, so now I have my access key and my secret access key. So this will make it so I can deploy from Terraform Cloud a new instance. All right, so from here, I'm going to go to settings. So under the workspaces, my TerraGoat workspace settings, and I'm going to go to general. And what I want to copy from here is this workspace ID. And I'll paste that in my notebook. So it's going to be off screen, but that's my workspace ID. I need that for the next step. And I need an API token. So the next thing I want to do is under user settings. I'm going to go user settings, and I'm going to do tokens. And I'm going to create, so I already have this Terraform login that for the Cloud9, I'm going to do create an API token. And let's just call this BC workshop. And I'll delete that later. So it's going to show up, copy that, done. All right, so I have that. I'm also going to paste that in my notebook. And so at that point, I should have the workspace ID and a token ready to go. Now I'm going to head over to the Bridgecrew platform, and I'm going to go to integrations, and I'm going to add an integration. So Bridgecrew, integrations, add an integration. And there are two here you can see. Let's do the Sentinel one. So in this case, token name, we called it BC workshop. Create that. Let's just copy that and add it to my notepad of secrets, which I will obviously delete. Okay, and then in the Terraform, so the next step, we have that workspace ID. Should look something like this. And then the workspace name, TerraGoat, the workspace description, and the token. That token is the token that we got from the user settings in Terraform Cloud. And then just add in a description and do next. All right, so it's okay, don't worry about this part. We'll get to it in just a second. What we're gonna do from here is go next. And then here's this, the integration code that we need to use. So I'm going to copy that. And the reason why is we're going to do a more simple workflow than adding this to our VCS. So from here, I'm going to take this and I'm going to copy it. And then I'm going to head over to Terraform Cloud. I'm going to go back to my org, go back to TerraGoat. And under here, I'm going to go under, under the master settings. And I'm going to go to policies. And let me just delete these real fast so I start fresh. If you just set up your Terraform Cloud, this is not a step you need to worry about. All right, so under policies, so again, I'm in Terraform Cloud. I went to the master settings up here, top of the top bar, and then I'm going to do create new policy. And policy name, I'm just going to call it Bridgecrew. Description, I don't need one. Now enforcement mode, we're going to do advisory. And the reason why is we know there are a bunch of misconfigurations. We're going to apply it anyway. So once we do that, we can paste the code that we copied over from Bridgecrew. So again, in the integrations page, after going through the Terraform Cloud integration steps, I have this code. I'm going to copy it and paste it here. And then I'm going to create the policy because we're going to come back and add it to a policy set in just a second. And then under policy sets, let's create a new policy set. And then we're going to do no VCS connection. Again, this is just a simplified way of doing it. Okay, and we're going to just call it the TerraGoat set. And we're going to do this. You can either do selected workspaces. Since I only have one, I'm just going to do it on the one. Do connect policy. Just open this back up and you can see add. We have Sentinel parameters. That's fine. All policies. That's great. All right. And then under policies, go back to the policies. We'll go under policy sets. And we need to add in that TerraGoat set and then add policy set. So now we have TerraGoat set. Let's update it. All right, policy sets. So we have one policy attached, and then under policies, we have one policy set attached to this. So that's the point that you should reach where you have your Bridgecrew integration code, policy code here. And then you should have one policy set, TerraGoat set. And just to double check under policy sets, make sure you have a policy set with one policy. All right, from here, what we're going to do is we're going to pre-warm this integration. So go back to your workspaces, go to TerraGoat, and then we're going to go ahead and we're going to do a queue plan. You could also do start new plan here. I'm just going to do a queue plan. And this is going to fail. We know that because we haven't added that simple instance yet. Plan error, can't find simple instance. We're going to add that next. All right. So at this stage, everyone should have access to the Terraform Cloud from the GitHub applications. If I refresh this, you should have your Bridgecrew integration, your Terraform Cloud integration ready to go. And you should have your running AWS instance from Event Engine. So those should be all set up. And I'm just going to do next, done. All right. So from here, what we're going to do is we're going to, if you're following along, I am now on the test pull request. So what we're going to do is we're going to add a new pull request in GitHub, which is going to trigger both all three, the actions that we have already pre-set up in TerraGoat. We're also going to trigger the GitHub integration, which will show off, and then the Terraform Cloud integration. So all three of those should show up. So what we're going to do is we're first going to go back to GitHub and make sure I'm in my TerraGoat fork. So again, make sure it's yours. And what we're going to do is we're going to add a file. So let's go ahead and go to add, create new file. And where we're going to add this is Terraform / simple instance / and then we'll just call it ec2.tf. All right, so in the Terraform directory under simple instance, which is what we connected to Terraform Cloud, ec2.tf. And then I'm just going to go over here and copy this code and paste in here. And what this is doing, you can see in US West 2, where our event engine is, it's going to create a new security group, a new EC2 instance, that's an Ubuntu instance on a T2 micro, and it's going to attach that security group to it. All right, and from here, what we're going to do is we're going to head down to the bottom, and don't click commit directory, click create a new branch. And honestly, it doesn't matter what you call it, but I'll just leave the default, propose a new file, make sure it's committing back to your master, and then create pull request. All right, immediately you can see I've got my 3 expected integrations, my GitHub action with Chekhov, my Bridgecrew integration, and my Terraform Cloud integration. And what we're seeing here right away is the Bridgecrew integration with GitHub. So all these are code comments, just like you might get from a peer review, where we have a whole bunch of misconfigurations. This one's critical, where it's saying AWS security group allows port SSH port 22 all traffic. And then some low ones like tags that are not tagged, or resources that are not tagged. And if you scroll down here, you can see some that actually have recommended fixes. So in this case, EC2 instance is not EBS optimized. So this recommendation is just to add this simple line, EBS optimized equals true. And the nice thing with this integration is I can easily just go commit suggestion, commit changes, and that will commit this change. It will add that line to my code of my pull request automatically. So that's pretty cool. And you can see all of this is running. So we have here the different integrations. Let's see, if we head back over here to the runs, maybe see what's going on here. This one should have run. It's fine.
I think you might have to just rerun it again. The worker probably failed.
Okay. Thanks, Prakash. Awesome. Do you know if there's an easy way to quick trigger that? What I might do is just, why don't I just close this and I'll just open up another pull request.
Yeah.
All right, so delete that branch. Let's go back into code. And I'm going to add a file, create a new file. Let's do Terraform / simple instance. Make sure I spelled that right, ec2.tf. And then let's copy this. We'll create a new branch, propose file.
Well, before you do a pull request, one quick check. Can we make sure the path is set up on the workspace correctly?
Yep. So here, let's just cancel out of that. All right, under settings,
general. Scroll down. Terraform / simple instance. Okay, good.
Okay. All right, let's go to add a file, create a file. Create a pull request, let that run through. All right, give that a minute. All right, so here we have our code comments again. And this aired out again. Do you think Let me see if,
Can you
just
go?
to check.
Yeah.
Do you think having this slash
Ah,
is the problem?
maybe we can try removing that, but
Let's just delete this. All right, we'll go to add a file, create a file. Create a pull request. It wouldn't be a live demo without some issues.
okay, if it errors out, we'll just go and see what's going on, debug it.
Awesome. All right, that's still airing out.
Okay, can you go into the plan?
Mm-hmm.
Details. So what this is doing is, okay, Terragold. This is from 9 minutes ago. So that means it didn't even, the webhook didn't even run, right? So if you look at runs, so the thing is maybe, okay, maybe the directory should be there before you create the pull request on it. So maybe let's create the directory first, possible. Make sure it's thing, then we put the code in.
Yeah, actually, I think you're right. So I think if we do merge pull request, this will actually create the directory, which will make the run work. So let's do confirm merge.
And I think it's only for the first one. The full directory should be there for the workspace, but subsequent ones you can do your add new files, and the pull request will pick up the right one.
Okay, great. All right, so let's just check out. Yeah, there it is. So it's running right now, and it aired out. Let's see. Huh. Invalid. I've never run into that. Let's see.
Can we check the variables? Okay.
Taylor, I think I might know what this is. Did you use, so I think when you were getting the AWS secret key and all of that jazz, did you use the ones that were included in Event Engine? Is that correct?
Correct.
Okay, so for Event Engine, when you're logging in, it is doing the assume role. It gives you secret key, the key ID, and then it gives you a token. And that token needs to be provided for all calls, so that session token. So it looks like when you logged into Terraform Cloud, when you included that for the Terraform Cloud setup, that wasn't included. So for all of these calls, when you're using that secret key pair, you need to include that token. So what you might need to do is to go create an IAM user and give it its own access keys for it to work. Because otherwise,
can you just
fail.
use the session token that's there in the run?
Yeah, as long if that's supported by Terraform Cloud, and you can
it is supported by Terraform Cloud, so you can just put in the AWS session token and it'll be fine.
Perfect. Okay, great. So what we're going to do is go into Event Engine, grab that AWS session token, and then under variables, grab this. Oh. I lost that. Where did that go?
You can click AWS console and it should pop right back up.
Ah, perfect. Okay. Thank you. Grab that whole thing, Copy that. And then paste it. Let's make it sensitive and save the variable. All right. So we're going to do, what I'm going to do is I'm going to artificially tag this. Yeah, that same error. Great. So under the GitHub,
you can, just to test it, Taylor, just go ahead and then manually run it from the top. This will, yeah, just to validate.
All right, we'll run that.
So in this case, you're forcing, without the GitHub webhook, you're forcing the plan to occur within Terraform itself.
Okay, great. And you can see it's working now. Awesome. All right, apologies for that. So the things that you need to do is hit apply anyway, or merge pull request anyway. And then make sure you also have your AWS session token in there in your variables. So you can see policy check hard failed. Let's see. This string literal terminated. All right. So I think that should be all right. We should be able to just go under.
No, under settings on top, Taylor, and then you go to policies, edit that. There's something wrong here. We need to copy it again, probably.
Okay. Let's see. I don't know if there's a way to get back to that code. Let me just try and set up a new one. So I'll do add integration. And we'll go into Terraform Cloud Sentinel. Token name, let's call it.
Okay, one of the attendees said remove the line breaks from the codes on the lines of the policy. Are there any line breaks there? Can you see quickly? We might have missed something in Terraform.
Line breaks.
If you go to the Terraform Sentinel page, is there any line breaks?
Yes. Oh, that's weird. Okay. I need to work with our team to make sure that's fixed.
Yeah, thank you, Chris.
Yeah, much appreciated. Looks like there are a few of these. Okay, that should do it. Update policy. All right, let's try that again. And it's going to run through. You can see it's provisioning. Okay, great. Advisory failed. Let's see. Okay, that's not working. Let's see. All right.
So is that a URL issue to Bridgecrew? Basically, Sentinel is calling Bridgecrew, but then it's getting a 400, right? No, on the top, yeah.
Yeah, so let's see. That should be working. That should be good. It's reaching out, and it has the right authorization header.
Can this width be on a second line, or does it have to be?
Sorry.
So
This?
yeah, line number 4, should it be this? Doesn't matter. Okay. And then scroll down if there are any more line breaks. That's it, right? Are we missing something at the very end? No, that's it.
Try that. It's fine. Let's
you probably have to discard it first.
Oh yeah, good call.
On the yeah.
All right, we'll let that run. And the nice thing is, if this doesn't work, we can run without it. We've got enough of the integrations working.
Hey, Taylor, while we're waiting for that, or Prakash, someone had posted, this is super cool. And just side note too, this live troubleshooting, everybody's loving it. I'm enjoying it as well. This is great, even though it's a little bit, nerve inducing. But someone had asked, why haven't the other GitHub actions published reports to the PR?
So those, the other GitHub actions are CI/CDs. So it's actually completely separate workflows. So it's sending the information over to them to run. If you, for example, it'll send it over, it'll trigger the workflow in Terraform Cloud or under your GitHub actions. You can see here are the different GitHub actions that ran, but the pull request integration is specific to GitHub applications.
So it looks like we're having the same issue, right?
Yeah.
Okay.
So what I think we'll do from here is we'll go ahead and move on. Apologies for this. We might be able to figure it out in a bit, but I'm going to go ahead and confirm and apply this anyway. All right, so that should apply. Creating 2 instances. And I noticed my console is just having a little bit of difficulty because I have some cookies. Okay, we're good. So let me just make sure this is applying. It's going to create that security group and server instance, the EC2. All right, so that's now created and I can confirm that. Again, I went to Event Engine, and if you are in here, AWS console, open AWS console. And under, that'll bring you here. And what we want to do is look for EC2. Instances running, you should see 2, one for the Cloud 9. And there's Cloud 9, and there's our demo EC2 that we created. All right. So the next thing we want to do is we want to check. So now that we've checked that this is live and running, fantastic. Let's integrate with AWS. So if you're following along, I'm moved on to the module fix. And I'm going to skip over pull request fixes. We touched on those. What I'm going to do is I'm going to do a runtime integration, and then I'll show the projects page how you can do fixes from there. So first things first, go to Bridgecrew integrations, and then we're going to do AWS. So if you first time you click on integrations, just to show that, add integration, AWS. and we're going to do a read access. You could also do a remediation access, especially since this is an event engine. It won't matter if you give, some people are a little skittish giving remediation abilities, but in event engine, that shouldn't be an issue. But I'm still only going to do a read-only access for this and do next. And then it's going to create an IAM role and an SS notification. So just make sure you're okay with that and launch the stack. All right, so you can see it's got my stack name, and I need to acknowledge that I'm allowing it to open up and create a new IAM resource, and let's create a stack. And I'll give that a minute to stand up. Now, what this is going to do is this is going to allow us to read in misconfigurations in the actual runtime environment. So in that DevSecOps motion, we did the build time scanning with GitHub Actions, with GitHub, the GitHub integration, and with Terraform Cloud. And now we're doing it with AWS and runtime. And then with we'll be able to, or Terraform Cloud integration, you'll be able to trace that back. So you'll be able to find, drift. And what drift is it's whenever somebody goes into the AWS console and makes a change manually. So you've provisioned a resource using Terraform, in this case, an EC2 instance, and your Terraform should be the representation of state, like what actually is in the cloud in AWS. But if somebody goes in and makes a change, then those are no longer in sync, and looking at Terraform is no longer helpful because it's not an actual representation of what's in the cloud. And it's not necessarily a bad thing that people are making changes in the cloud, but the problem is that loses the value of Terraform. So somebody could go in and in an S3 bucket, turn off public access, which is a good thing, but now your Terraform that provision that S3 bucket is no longer the true state of what's in the cloud. So if you go to do a Terraform apply, it's going to try and overwrite that change of public access. All right, so we've done this integration now. We have AWS integrated. And if we go into, let's go back to our EC2 instance. And if I open this up and go to tags, so the BC workshop, not the Cloud9 instance, you can see all those your tags that we talked about before. And so what we're going to do here is we're going to now make some drift. So we have the integration now. Let me go in and let me just confirm here. So if I go under integrations, under incidents, under Bridgecrew.cloud instance, give it a second to load. What this is going to now have is a lot more misconfigurations because it's also going to have those runtime misconfigurations. So give that a second to load. Just do a refresh. All right, while that's loading, what I'm going to do is I'm just going to check in on the integrations. Okay, good. So the cloud provider, it's been scanned today. Make sure that's all good. And then under incidents, we'll see those misconfigurations both in build time and runtime. Okay, great. While that's loading up, what I'm going to do is I'm going to make some changes. So the first thing I'm going to do is I'm going to just add a new tag. And honestly, at this point, you can do whatever you want, cause a little mayhem. I'm going to just do a few simple things. So under my EC2, I'm going to manage tags. I'm going to add a tag. And I'm going to, let's see, let's call it test. Let's add a tag. Let's just call it Starship Enterprise. Okay, save that. So now this has a whole bunch of tags that weren't there before. And then under details or security, I'm going to view that security group that I made, the SSH traffic that was provisioned with Terraform. And I'm going to edit the inbound rules. And let's just add a rule. In this case, what I want to do is the MongoDB one. So custom TP is fine. TCP is fine. Let's do 27017. That's Mongo's, and we're going to make it anywhere IPv4. Just call it Mongo. Save that rule. All right. So, and then outbound rules, by default, these are all set to everything, but let's just make that the case. Let's do all TCP. And I'm moving fast here because honestly, it doesn't matter. It's whatever changes you want to make manually. All UDP, anywhere. Let's save that rule. All right. So we've made a bunch of changes to the EC2 instance. We've made a bunch of changes to the SSH. Now what I'm going to do is I'm going to trigger a scan. So normally what happens in Bridgecrew is you have scans only every few hours that will identify drift and new misconfigurations or things like that are triggered, like pull requests. In this case, I want to artificially trigger a scan early. So what you can do to do that is under drift detection, you can check out this curl command that's just going to reach out to the API, and that'll trigger a scan. So under Cloud 9, that should be good. All right, we're back. Let's just do that curl command. Great. So it shouldn't give any output. And what that's going to do is it's going to trigger a scan again. Now, this drift detection does take a minute or two, so there's a good chance that it's not going to be ready quite yet. We'll see if it's working. But what I would expect is under the projects page, so bridgecrew.cloud, under the projects page, under my GitHub repo, I'm going to go to the TerraGoat repo. Give that a minute.
Hey, so Taylor, just a quick question. So the project basically has a whole bunch, it's a list of repos, right?
Yep.
So let's say, sometimes we have in a single repo, you might have different branches, one branch for test and one branch for, dev. How would those show up? How the branches will show up within the repo?
Yeah, that's a good question. So once this loads up, you'll be able to see that we have the ability to do not only the master branch, but any of the other branches that you have in your repository. Okay. So it looks and feels kind of like a repo itself. This is
Taylor, while this is loading, I had another quick question here, and kind of just to revisit earlier when you talked about the breakout between leveraging Chekhov locally, but then leveraging an API key so that you publish some of those repo scan results. In that same token, within the repo, when you have a GitHub action, Chekhov, for example, the question was around, as far as I know, shouldn't the Chekhov action also publish its result? So I don't know if this is maybe a conflation of the Bridgecrew icon with the Chekhov GitHub action, but that's what someone was asking.
Yeah, it's a good question. So Chekhov can be run with or without the API key, and that's also true in the CLI. So just in any integration that leverages the CLI. So if you look at the actual workflow, let's go under Chekhov, you can see what it's running here. And it's actually just running the GitHub or the Chekhov scan. And so what it's doing is it's not, okay. Right here, you can see that it's running the install Chekhov just like you would normally. And then what it's doing is it's running Chekhov right here, directory, Terraform, oh, failed only. So you can see what's missing here is the API token. So just like when we ran the Chekhov-F without any API token, how it didn't send any information back, this is the same situation. It's not connected to the Bridgecrew platform. It can run completely independently. And this is helpful in isolated environments. So if you have like a GitHub Enterprise on-prem or Bitbucket on-prem, you can still run Chekhov locally. But if you want to actually have have this CI/CD scan, GitHub Action scan show up in Bridgecrew, you need to add in that API token. And if you go through the integrations page, rather than just using this TerraGoat implementation, it will include the API token automatically. So I'm going to give this one more minute to load up. If it's not, there we go. All right. So the Bridgecrew under projects page, you can see here. So we have, we can do the view PR to Prakash's question. I can see a whole bunch of the PRs that I have here for feature branches. But let's go back to the master. And you can see there's a whole bunch of misconfigurations here for all of Terraform. So it's a nice layout of all the different misconfigurations. And then under AWS, what it has is, it also has fix suggestions here. So in this case, it's an S3 bucket that doesn't have encryption turned on. It will actually provide you the code to make that work. And if I just do fix submit, it'll open up a pull request to make that fix automatically on my behalf. And so actually, I'll go ahead and do that, and it'll submit, and I'll show you what that looks like. It'll open up a pull request in GitHub. Now, what I would also expect it to see, but it just because the scans take a little bit, is drift. And so if you're trying this at home, give it a few, maybe a couple hours after we're done with this, and run that API command again after making a whole bunch of manual changes, and then drift will show up. And I'll just show you a preview of what that looks like in a different account that I have. All right, so this is just another account that I have. You can see it's still that TerraGoat repo, but it'll show up. Notice drift detection, and it actually gives you the ARN for the resource, which makes it a lot easier to find. And then it will show the actual changes so that have been manually made. So in this case, somebody went through and deleted the tags in this environment. And so that will show up. And then somebody deleted these tags, somebody deleted the your trace, and then there's some additional stuff like MFA was turned off. So that's what drift will look like if you give it a shot in a few minutes. And then I saw a question here for the projects page. I think what is being asked is for the workshop or demo, TerraGoat. So I'm not sure if I'm answering this correctly, but I think the question is basically on the projects page, what we're looking at is our repo, TerraGoat repo. So that's most of what we wanted to show off. Now, I know that we were having a little bit of difficulties with Terraform Cloud. So what I wanted to show in these last 20 minutes or so is I wanted to show what it looks like. Just make sure drift is not, yeah, it's not there yet. So if we go back to the instance page, let me see if that's up and running yet. Okay, great. So you can see here all the different runtime and build misconfigurations across my different accounts. So projects is really good because it looks and feels like a repo, and it's really easy to find the different misconfigurations. And then you can also use things like git blame or git blame integration to find out who exactly owns that resource. So in this case, you can see Nimrod was the last one to modify this. In this case, Barak was the most recent to modify this resource block. I can also search by, so I could say, let's just look for Matt Johnson. And here are all the resources Matt Johnson has modified and the misconfigurations that he has. And then you can see there's a search functionality, so I can search for a specific resource or a your trace if I want to use that, along with some additional information, including dependent resources. All right, and then let's see if I'm going to check one more time if Drift is ready. If not, then I'm going to show off the run task integration. Okay, so that's not quite ready to go. Let me just make sure all accounts are on. Yep, we're good. Okay, so my recommendation is in a few hours or so, come back to this and then try that API call again, the curl API call. And that will just automatically rescan and it should identify that drift that I showed off from my other account. All right. Yeah.
Oh, sorry. Quick question. So under the hood, Bridgecrew saves the state, and then it's kind of reverse engineering the state, the code from AWS to compare it. Is that what's happening? Like, how does it detect the drift?
So the drift is basically there's two ways, right? So the one way is it takes the Terraform plan information that's stored in state in Terraform Cloud. That's the one that I wanted to show off. And then the second one is if you've integrated with your repository, and it doesn't matter if it's GitHub, GitLab, Bitbucket, then we'll use that as the state. So we'll just take the Terraform files that you have stored in the master branch and assume that's the state that should exist in the cloud. And then we'll compare that to the actual state in the cloud. And the nice thing, what we're doing on the back end is we're converting the state in the cloud to HCL so you can compare apples to apples. So you can see here, like here's the runtime resource and it's converted it into HCL. So we can actually do that apples to apples comparison and see if there's drift.
Okay, sounds good. Awesome.
Yeah. Cool. Okay, so let's show off the run task. And again, this is in beta, so there's always a chance it might not work, but it should work as planned. So we'll give it a shot in the spirit of more live demoing. Okay, so under integrations, add integration, let's go this time to Terraform Cloud run tasks. And then this time, so you follow these directions, we'll open up this user settings page. Let's make a third token. Let's call it run task. Copy that. Let's say done. Plug that in here. So again, integrations, add integration, Terraform run task. Hit next. Prisma demo. In this case, I can either make it mandatory or not. I'm going to not make it mandatory. I'm going to do the TerraGoat repo, and then I'm going to hit next. And what this is going to do is it's going to make API calls to Terraform Cloud to automatically set up our run task integration. All right, so that one's up and running, which is great. Now, just to head back over into Terraform Cloud, if I choose an organization, Prisma Cloud or Prisma Demo, TerraGoat. If I take a look under Settings, Tasks, which is under Beta, you can see the Bridgecrew integration is there and ready to go. So now I'm going to do another just plan, and let's see what happens here. And you can see it looks very similar to the run we did before, with one additional place here. So we have that policy check pending, which is the Sentinel integration. And then we also have our tasks pending, which is the new run task integration. It's doing its cost estimation thing.
Hey, Taylor, while it's doing that, there's some questions. So what is the typical workflow? So drift is detected on the UI, right? What are the things the user can do? What are the different options?
Yeah, so it's a good question. There's really two options that you can do if there's drift. So the first option is that you can rerun Terraform apply. And so that will take whatever you have in Terraform and make that the state in the cloud, because it'll make all the changes for you. Or you can do fixed drift. So in the case of Bridgecrew, what we have is a tool that will automatically make the change. So looking at this drift here, I can do fixed drift. And what that's going to do is it's going to open up a pull request back to GitHub or whatever repo you have with these changes made. So the idea is if it's a change that should have been made, somebody went into your AWS console and manually turned on encryption for S3, then you do fixed drift. And that way encryption is turned on in the Terraform. If it's a change that shouldn't have been made, let's say it's a break glass moment and somebody turned off or opened SSH to the world just so they could SSH in from a different location, that's a change that shouldn't have been made. Then you just do Terraform apply, and that'll bring the SSH open to the world back out of the platform, out of AWS.
Okay, and the drift, the system will automatically do it every few hours, you said, right? Do we know the time? Like, is it 4 hours or 2 hours?
So currently it's twice a day unless you manually trigger it. So it's every 12 hours.
Okay, cool, thank you.
Yeah. Great, so you can see here the task passed, and the only reason why it passed is because we know we have a whole bunch of misconfigurations. It's because we put it in advisory mode. And then if you click on this details button, it'll bring you back to the Bridgecrew platform. It'll show that Terraform integration. It'll show it's a run task. It will have all those misconfigurations that it found across here. And it's running it on the plan itself. And so you can see all the misconfigurations in that plan, along with the severity level and what's wrong with the run task. So thankfully that was a little smoother. Apologies about the Terraform Cloud Sentinel integration. I'll make sure that that's fixed on the back end. But we're now ready to go with the run task if you want to use that instead. Great, so 15 minutes left. I'm just going to leave 5 or 10 minutes for any additional questions. Let me know if you have any. You can put them in the chat box or the Q&A section.
Yeah, Taylor, if drift is detected, how can we set up notifications for that?
Yeah, so we do have notification engine. If you go through the integrations, add integrations, you can check out all the different notification channels we have here. So Slack, Jira, or Splunk. Jira and Splunk are, Jira is more manual, where if you have a misconfiguration, then in Bridgecrew, you select create a ticket. And that's just because we found from our users that that's more the workflow they want to use. But Slack is on demand. So it's a push model. So as a new misconfiguration is identified, it'll show up in a dedicated Slack channel. And I did notice in my projects page, so we have now that drift. So under the GitHub integration, it's taking a minute, but okay. Well, yeah, so the different notifications are there, and we're going to be adding some more soon. So you can expect more integrations for notification channels. Any other questions I can answer?
While you're waiting for more questions, so So in the project page, you have the different repos. Where do you see the run-based errors, like history of runs? Can we see that?
So in runtime, under incidents,
Okay.
it'll show you all the different misconfigurations. And then you can also see an audit history. So let's just filter for just so this numbers is my AWS account. So if I just filter on that and look for, oh, there's our drift.
Okay.
Wonderful. So drift is in, but you can see here, if you open up one of these resources, it'll not only show you the misconfiguration or change, it will also show you a resource history.
Okay, got it.
Yeah, and drift is showing up here. So it shows up in two places. It shows up in the projects page and on the incidents page. You can see all these changes that I was making. Some of these are just default changes here, but like I added these tags. Now that's showing up in this resource. And if I go back to the misconfiguration, and let's open up the security group. You can see here's that where I added in the open to the world 2701.
So cool. Quick, I know we have limited time, but can we quickly see how you create a new policy from the UI for Bridgecrew?
Yeah, that's a great question. So under the policies page, so there's multiple different ways you can create custom policies. One is in Checkov itself, you can add a policy in Python and in YAML. And we have some resources that online where we show you how you can do that. We also, under our projects page, under our policies page, have a new policy section. So it's where you can go and you can create a new policy, and let's just call it test and guidelines, none, category. And the nice thing is it gives you options here. General, so let's call it severity, critical, and then the provider, in this case, AWS. And then this example here is actually a good one to show off. I can just uncomment all this out. So this will actually guide you through how you can create a new policy, and then you can actually run a test of it. And it'll show you all the policy, all the resources you already have onboarded that violate this policy. So in this case, I've created an OR block that says either the AWS instance is type T3 micro or T3 nano. And anything else violates that. So if I open this up, you can see T2 nano. So it violates this new policy that I've made that says you're only allowed to use T3 micros or T3 nanos because somebody tried to provision a T2 nano. This is just one example of how you could do it. And then if you hit done, that custom policy will show up anywhere you have your API token. So if you just run a local Checkov without the API token, it won't be included. But if you include the API token, then it will include this custom policy that you've built. It'll also include any suppressions that you've made from the platform. And that's also true. We have a VS Code integration that will scan your code as you type it out. These custom policies will automatically show up in there. And then we also have a visual editor. Let's just discard that if you'd rather go through a visual editor.
Taylor, another on drift detection, and this, let's say specifically from a GitHub action, which triggered the Terraform plan. Will it stop further execution at that point?
I'm not sure I understand the question, but let me see if I...
More of what when it discovers, yeah, I see. Yeah, I'm trying to kind of.
So drift is more, it's not something that would be detected during the build phase. It's something that's detected once somebody makes a misconfiguration in the cloud. So if there's a change, it would just look like any other change in the build phase.
Oh, that's
so
right.
It's not something we would block.
Yeah, so yeah, now okay, now I get where the question's coming from. So from the drift detection, as Taylor mentioned earlier, you will have these APIs check-ins that'll happen every 12 hours, but you could also trigger that manual API call as part of a pipeline or something as well too.
Right, right. But we won't block based on drift, because drift to Terraform just looks like, oh, I'm making another change. So let's say you've turned on S3 encryption in AWS, and then you go to apply Terraform. It's just going to look like Terraform is just going to say, oh, I just need to turn encryption back on. It doesn't know that it's drift. Great. Well, so we have 5 minutes left, and thank you so much, everyone, for joining. Really enjoyed this. Apologies about the Terraform Cloud integration, but we're showing off run tasks, so hopefully that gave you a better idea of what we can do. And then also a big thank you to everyone who joined on the back end. I couldn't do it without you. So Prakash, Jason, Yaniv, and Michael, really appreciate the support on this and really enjoyed it.